Attendees are in listen-only mode.
Hello everyone, welcome to today's webinar, the first in a series of 3, Deep Energy Retrofits, Vision, Goals, and Process. My name is Connie Umfris, Communications Manager for New Buildings Institute. Before we begin, I have a couple housekeeping things to tell you about. First, you are muted and we cannot hear you. This helps keep the background noise down so that everyone can better hear our presenters. I want to direct you to the dashboard that you should be able to see on the right-hand side of your screen. If you are having technical difficulties and cannot see the slides or hear our speakers, you can use the question pane in this dashboard to let us know, and we will help you as we go. During the webinar, we'll be asking a few polling questions, and you can use the dashboard to respond. We will take questions at the end of the webinar, but you can ask questions anytime during the session using that same question pane. At the end of the webinar, you'll be given the opportunity to take a short survey. During the survey, you'll be able to enter your AIA number to receive continuing education credits for this webinar. Our panelists today are Tracy Beckstrom of National Grid and Sean Deniston from New Buildings Institute. Tracy Beckstrom is the lead in the Energy Efficiency Commercial New Construction Group at National Grid, responsible for the implementation and delivery of the large commercial and industrial new construction program, including advanced building and comprehensive design programs. Previously, Tracy was the manager of strategic initiatives at New Buildings Institute, responsible for developing and maintaining new and current sponsor relations. She facilitated the integration of NBI-developed tools, guidance, and information into utility and public benefit programs. Prior to joining NBI, Tracy was the lead program manager, new construction at Eversource, running a team of program managers in implementation and delivery of large commercial and industrial new construction programs, including advanced building and comprehensive design programs. Tracy has a bachelor's degree in economics from Clark University. Sean Deniston uses his expertise for code analysis, tool development, and research. He also manages New Buildings Institute's Advanced Building Program, which provides technical resources for new construction projects. Sean earned his bachelor's degree in architecture at the University of Oregon and a master's in historic preservation at the University of Pennsylvania. Sean's work at NBI includes analysis and review of data relative to commercial building energy performance and prediction, code and energy program effectiveness, and energy technologies. He also does research and review of commercial building design practices and energy and green technologies, including application, costs, savings, and reliability, preparing analysis and graphics on commercial building energy use. Welcome.
Thank you, Connie. Appreciate that. Tracy Beckstrom here. Just going to talk a little bit about National Grid. We cover 3 states, Massachusetts, New York, and Rhode Island, and you can see we cover both gas and electric in Massachusetts. Boston is our gas territory. We cover both gas and electric all the way up to the border of New Hampshire, down to the South Shore. We cover all of the gas for Cape Cod. We go out to the central part of the state, gas and electric, and also to the western part of the state of Massachusetts. In New York, we cover both gas and electric in upstate New York and in the Long Island area. And not to be forgotten, our small state of Rhode Island, we cover all of the gas and electric in Rhode Island. So in total, we service about 3.4 million electric customers and about the same gas, about 3.6 million customers, gas and electric. And we are the second largest utility in the Northeast. And we are owned by UK National Grid, so we are owned by a UK company.
Next slide, please.
And at National Grid, one of the things that is really near and dear to our heart and very important is safety. Safety not only of our employees, and it doesn't matter at National Grid whether you are somebody that is at a desk all day or you're out boots on the ground. We take safety very seriously, both for our employees here and for the public. So we always like to share a safety moment just to remind people about an area of safety to be aware of. So spring is here. All of us have been cooped up. Spring's supposed to be here. New England hasn't been here in the last couple of weeks, but everybody's planning their outdoor projects, getting very excited about getting out there, getting into their yards. Also, contractors are much more active. So we want to make sure that in your enthusiasm, you don't forget to call 811. So if you're going to be digging, any kind of digging going on, whether it's just as a residential customer or if you are a contractor, please make sure that you call that number. Make sure that you're safe. There can be very catastrophic results if you don't do this. And once you do, you can go out there and enjoy the spring and get your projects done. So just make sure that you call that line before any digging happens. Before Sean gets started, we want to talk about a little bit about how the deep retrofits relate to the efficiency programs. Essentially what happens is when you do a major retrofit, it triggers code. So code is what really drives our new construction program. So it gets a little bit confusing that this is a retrofit discussion, but essentially what happens, anytime you trigger code, we use the baseline of whatever code you're at. In Massachusetts and Rhode Island, it's at IACC 2012. In New York, I believe it's IACC 2009. So all of the savings and all of the incentives that we offer are from code. So as an example, if you have a chiller that you are replacing, say it's a 20-year-old chiller, you need to bring that chiller up to code, and the incentives that we will offer you are from code to a better piece of equipment. So our goal is to really support our customers in going above code and making sure that because you have that opportunity at the time, you're probably not going to replace that piece of equipment for 20 years perhaps, that you really look at how you can replace that piece of equipment with the highest efficiency piece of equipment. So what we want to make sure that we get across here is that the owner is going to get the full benefit of that of a deep retrofit. So you're really going to get the full benefit of going from the existing piece of equipment to the new piece of equipment. So that is something that is really important to understand here. We will offer the incentives to help support you get from that code compliance trigger to a much more efficient piece of equipment. We really, our goal is to really get you above code when you're doing one of these deep retrofits, and that will really help reduce the ROI for this upgrade, and then you'll have the benefit of that piece of equipment over the next 20 years. You'll get the savings as you move forward.
Thank you, Tracy. As Connie introduced, my name is Sean Deniston, and give you a brief introduction to the New Buildings Institute. We are a nonprofit working in energy efficiency in commercial buildings, redefining what's possible in the built environment. Our vision is that we believe a built environment can make a contribution to the sustainable society through improvements in energy performance. We take leading edge practices in technology and applications for high performance buildings and translate them into innovative and practical solutions for the energy efficiency and commercial building industries. Since we are a nonprofit, we have what we call the virtuous cycle, that we start with thought leadership and transform that into practical research, digging into new topics, use that research to create solutions for the markets like design guidance and tools. Based on what we discover in the market, turn that into a vision that we can then move these concepts into codes and policy and then start the cycle all over again. Now, since this webinar does qualify for AIA credits, we have the AIA boilerplate. New Buildings Institute is your provider today, and Sean Deniston, me, as the presenter. And the title of this session is Deep Energy Retrofits, Vision, Goals, and Process. And of course, the number is NBI DER01. Credits earned on completion of this course will be reported to AIA CES for AIA members. Certificates of completion for both AIA members and non-AIA members are available upon request. This course is registered with AIA CES for continuing professional education. As such, it does not include content that may be deemed or construed to be an approval or endorsement by the AIA of any material or construction or any method or manner of handling, using, distributing, or dealing in any material or product. Questions related to specific materials, methods, and services will be addressed at the conclusion of this presentation. And the description of this course is a deep energy retrofit is a retrofit project that achieves at least 30% energy savings in a building. Success with this kind of project requires more than widget-based retrofits with a focus on one-item upgrades into buildings. This first webinar of a three-part series will focus on vision, goals, and process in deep energy retrofits. The webinar will address how the design approach to these projects must differ from high-performance new construction projects, how to identify good candidates for deep energy retrofits, and the tools and resources available. At the end of this course, you all will be able to understand the meaning of a deep energy retrofit, understand how to identify opportunities for deep energy retrofits both within a particular project and in groups of projects, understand the steps required to assess building conditions in order to support a deep energy retrofit, and understand how to assess different deep energy retrofit strategies for a project. All right, now that we're through the boilerplate, I don't have to read slides to you anymore, and we can get to the interesting stuff. So the first question here is really, what is a deep energy retrofit? And I think that this is really important, especially in the Northeast, because this is a concept that has been defined a couple of different ways. And we're talking about commercial buildings, and I know that sometimes, especially in the Northeast, there has been a residential movement around deep energy retrofit, which has a definition all its own. So when we say deep energy retrofit, we don't necessarily mean a major renovation. It's a prime opportunity to do a deep energy retrofit, but you don't have to do a major renovation to get this kind of savings. I know a lot of people will think a deep energy retrofit is going to require reskinning the building, doing something really significant, or if not replacing the building, like this example from Canada, at least doing a major retrofit of insulation. Or people might think that it's going to require completely replacing your HVAC system, or perhaps just gutting your spaces and making them into spaces that are very different with fundamentally different systems. And that's not necessarily the case. So if a deep retrofit is not necessarily all of these things, then how are we defining it for the purposes of this webinar? We are defining a deep energy retrofit as any retrofit that achieves at least 30% savings above the existing conditions. Now, usually that is going to mean impacting multiple systems, whether or not you're replacing them. It's going to involve some full system replacement, but maybe not all of the systems. You probably will be doing retro commissioning, probably be taking measures to reduce infiltration, since that is an increasingly driving factor for inefficiency in buildings, and maybe some upgrades to the controls. But on some projects, it can look very different. Sometimes it means just replacing a single system. Sometimes it can mean just retro commissioning alone, or almost only retro commissioning. Some weatherization programs have seen 30% savings. And sometimes you can get to 30% with only no-cost and low-cost measures. The point of this is that depending on the building is going to define the scope of what a deep energy retrofit is in your particular project. Because sometimes it could mean ultra-high performance, ultra-low energy buildings. It could mean significant reductions in energy use. And maybe if you add renewable systems, it's going to mean zero net energy, such as this, the Zero Net Energy Center in San Leandro, California, which achieved 75% savings over the baseline, added renewables, and achieved zero net energy as a deep energy retrofit. So we're going to ask you all a couple of questions for audience participation. Connie?
Okay, I'm going to go ahead and launch these polls. Give you another couple seconds here since we have two.
Connie, we're just going to read these off.
Oh, yeah, go ahead.
Where does your company, sorry, oops, never mind. You can read them, Connie, sorry.
Okay, where does your company primarily offer its products and services? The choices: Metro New York City, Long Island, Upstate New York, Massachusetts, and Rhode Island. And I'm going to go ahead and close this out here in a second, so make sure you vote. Okay, looks like we've slowed down here. And the next question, what kind of products and services does your company offer? We have architectural, engineering, design build, energy consulting, and other. All right. I'm going to go ahead and close this. We've just about slowed down here, so I'll give you another second to vote. All right. Go forward.
Thank you, Connie. We always like to ask some questions of our participants to see what your interests are, where you are. It'll help us tailor our forthcoming webinars to better suit your actual needs. So let's look at how it is that you do a deep energy retrofit. So we'll say deep energy retrofits in 5 easy steps. The first step, and this is probably one of the most important steps, is assessing the building itself, assessing its performance, its weaknesses, its strengths. Then, based on an understanding of where the building is, you set goals for the building's performance, how much you want to improve, or if there's a goal like the Architecture 2030 challenge or zero net energy that you would like the building to meet. With the goals in place, you define the scope of the retrofit, figure out the measures that will get you to that goal. What combination of measures, because it's almost always going to include a combination of measures. Once the design is made, implementation of the measures is critically important, especially in an existing building, to ensure that the measures are installed correctly and operating correctly so that moving into the future, you can operate the building successfully. Because one of the opportunities of a deep energy retrofit is to impact not just the static building itself, not just the material of the building, but the way that the building is operated. So we're going to ask you another question here, Connie.
Okay, let's see. Do your major renovation projects have a dedicated energy budget? And that is open now. Okay, just a couple more seconds to get your vote in. Okay, thank you.
Thank you, Connie. So looking at these 5 steps, in today's webinar, we are going to focus primarily on assessing the building and setting goals. And especially, as I said earlier, assessing the building, since that is one of the things that really sets a successful deep energy retrofit apart. In subsequent webinars, our next two will be focusing more on scoping, implementing, and operating. So we won't be addressing those steps in the process as much today. And the reason that we want to really emphasize assessment is because that's what sets a deep energy retrofit, or really any retrofit project, apart from new construction. So here we have two university projects, and on the left you have a new construction project, and on the right an existing building. So on the left it's a building that doesn't exist. Here are some of the drawings for the presentation, and on the right a building that has existed for quite a while. Now, with a new construction project, the design decisions shape the building. You're dealing with maybe not entirely a blank slate, since we do have site constraints and programming constraints, but how much insulation, the system type, the configuration, where the windows go, these are mostly up for grabs for the designer and for the engineers in deciding what this building is going to be. So the design decisions shape the building. But in the case of existing buildings where we do these retrofits, that's not the case. The windows are where they are, the systems are what they are, and the configuration is what it is. And so the building really shapes the design decisions. And so a successful project, the design team and the owners need to have a good understanding of that building, of its weaknesses, its strengths, its opportunities before moving forward, before selecting the right things. They can't just decide, well, we want to have a super insulated building like they might with new construction. They have to see if that measure is compatible with the building that they have in front of them. And so one of the first steps in the assessment is to find out whether or not a deep energy retrofit is even appropriate for this building, because it may not be appropriate for all buildings. And that really begins with the energy performance of the building, the energy use, and one of the easiest ways to get at that is to start with your utility bill from National Grid or wherever you might be. And we use that to generate one of the most common energy metrics in buildings out there, which is the energy use intensity. It's simply the annual energy use, that's divided by the square footage, and that gives us the energy use intensity. And that's really useful. It's out there in a lot of places. You hear a lot of people talking about the EUIs when you are dealing with disclosure ordinances. They almost always ask you to disclose the EUI so that buildings can be compared to each other. But say you have a building, and this is the Boston City Hall, and we just happen to know what its annual energy use is because Boston is disclosing these things, and it has an EUI of 122. But what is 122? Is that a good EUI? Is that a bad EUI? Is that a really ugly EUI? These are the sorts of things that maybe some of you on the phone know. You have a grasp of what are good and bad EUIs for this particular building type, but maybe your client doesn't. And so the really important thing is to offer context for that number, for the energy usage of the building. And there are a lot of ways to do that. Energy Star is probably the most common one. It's something that a lot of buildings are making use of, the Energy Star Portfolio Manager, because it collects all the data in one place, and it will even give you an Energy Star score. And while the Energy Star score begins to break down at really high levels of performance, they tend to bunch in the high 90s. For a lot of existing buildings, this score is really good for giving context. It's 0 to 100. The closer to 100 you are, the better your building performs relative to the data set that Energy Star is looking at. So 86, that means, well, it means what it means. It means that if you operate over time and improve it, that you're improving your building. If you see your number dropping over time, you know that the building is getting worse. Another way that we can begin to look at context is ASHRAE's building EQ, which is, instead of a number, it's a letter grade. And one of the nice things about this is that it can be applied to both a designed building and to the building in operation. The better it is, the better the grade is, and this gives context. And then there's another one, which is the ZEPI scale, which is Zero Energy Performance Index. And the nice thing about the ZEPI scale is that it aligns with things like the Architecture 2030 Challenge. On the scale, 100 is equal to the average performance of a building at the turn of the millennium, which just happens to also align with the CBEX, the Commercial Building Energy Consumption Survey from 2003. So a large data set of buildings, you can compare your building against that data set, and if you are the same as that average, you're 100, going all the way down to 0. And we can also peg things like the 2030 challenges. So the 2015 challenge equals a 30 on the ZEPI scale. We can even peg code levels to this scale. So we know that the 2012 IACC, which is what a lot of you will be dealing with for at least a few more months, is a 57 on that scale. So if we take this building that we knew what its EUI was, we can see that it has a ZEPI score of 144, which is really up there. It means that it's performing quite a bit worse than the average building was performing 16 years ago. And that's a lot of context right there, just from that score. But there are other ways that you can assess EUI as well. This is the ASHRAE Standard 100, which has a few tables that give target EUIs for being in the best quartile, the 75th percentile, which is the bottom quartile of that same data set. So lots of ways that you can give context to that EUI. So you can't just stop at the EUI, you need to give context to see how that building actually relates to other buildings and to other standards out there. And that's the thing that we really want to emphasize. Lots of different tools available, but the context that they provide is key because that lets you know where you're starting with the building. The more of a dog the building is from the beginning, the greater opportunity you have for getting deep energy savings out of a project. The easier it's going to be, the lower the fruit is going to be hanging. But there are also other ways that you can look at deciding whether or not it's time to do a deep energy retrofit, because performance isn't the only other thing. Every building has a life cycle. So this is a building in Albany that has its own life cycle. And if we think of the life cycle of a building, it has major cycles like major renovation. Every 30 to 50 years on average, commercial buildings in the United States go through a major renovation, which is renewing the building in a project that is very similar to new construction. Lots of systems, lots of materials being removed and replaced and upgraded. But there are narrower cycles. HVAC systems generally last 15 to 20 years. Unfortunately, they're often pressed into service far longer than that, resulting in inefficiency. But 15 to 20 years, you should be seeing system replacements from the HVAC. On the other hand, lighting retrofits average every 5 to 7 years. And unlike HVAC equipment, where it's actually performance and the equipment running out, lighting retrofits are driven more by market trends, because lighting retrofits are one of the most common things that happen when new tenants move in, such as during a lease renewal. In commercial buildings, on average, lease renewals are every 2 to 5 years, depending on the market, and so that provides another opportunity. And real estate transactions, whether it is these smaller lease renewals or larger events like sales, which might coincide with a market repositioning. And then, of course, there are things like unexpected repairs. Your HVAC system catches fire or blows up or just wears out, or weather events like hail that can do damage to buildings, or less acts of God and more acts of man that might happen to your building. And those repairs present opportunities to do efficiency upgrades. All of these are inflection points in the life of a building that provide opportunities that maybe this is the best time to time your retrofits and to make the most of them. The other thing that looking at your building this way allows you to do is maybe you have a great deep energy retrofit combination of measures that you want to do, a big project, integrated design, but you can't do it all at once for capital or for usage reasons. You have tenants in there and you can't just be booting them out so that you can do things. If you look at these elements of a building's life cycle, you can then time the parts of your deep energy retrofit and do it in phases where it coincides with the life of the building. That you might do things like major insulation upgrades at major renovations, timing that lighting retrofit at lease renewal, maybe trying to time your HVAC replacement at the same time. Maybe trying to time a larger body of retrofit activities to when a new owner is coming in and is interested and repositioning the building in the market. Successful deep energy retrofits start with the right building. And this gets back to this idea of understanding how the building is performing and whether or not it is already performing fairly well or not. So let's look at two examples I think people would really understand. A hybrid that maybe gets 51 miles per gallon and a beat-up old pickup truck that gets 12 miles per gallon. Because a 30% improvement in a hybrid is going to 73 miles per gallon, and that's pretty impressive as far as performance goes. And that's savings of 88 gallons per year. But in the old pickup truck, a 30% improvement might only mean that it's going to 17 miles per gallon. But that's 375 gallons per year of savings. So the same percentage of improvement in these two different vehicles has a tremendously different level of savings in the money that it will save to the owner. And we know that a hybrid is very sophisticated in the systems and has already been optimized for efficiency in so many ways. So getting that additional 30% can be really difficult. How much more efficient can you make the drag profile of the building, of the car? How much more efficient can the batteries really be made? How much more efficient can the engine be made? Well, with that beat up truck, oiling the chassis and doing really simple things can make a huge difference. And it's the same way with buildings and the sort of thing that you want to evaluate when deciding whether or not the building that's in front of you is a good candidate for a deep energy retrofit. You can also, instead of looking at an individual building, begin to look at whole portfolios of buildings to decide which ones in the portfolio would make a good candidate. And as disclosure ordinances come out and as holders of larger portfolios of buildings are beginning to pay more and more attention to the performance of their entire portfolio, then this makes a lot of sense. You can look at a whole bunch of buildings and see that, well, here we have a whole bunch of site EUIs. Using something like ZEPI, we can give that context so that we can rank them all next to each other. Maybe we even look at where they fall in the percentile so that we know not only how they perform absolutely to this absolute standard like ZEPI, but we know how each of these individual buildings perform relative to each other. And of course, data is never perfect, so you're going to have some errors in that. And this can allow you to set standards that, well, these are the buildings we want to take a closer look at to see if they might be candidates for deep energy retrofits. And we know that these are dogs, and so we know that these worst performers really are candidates for deep energy retrofits. And these are the ones that we're going to focus on. So you, as practitioners, and I think probably most of you are practitioners, this is a service that you can provide to your clients to help them identify good candidates for deep energy retrofits and help them to focus their energies on where it's going to make the biggest difference for them. So we have another poll for you all. Connie?
Okay, have you worked with National Grid on an energy saving project in the past? Go ahead and launch that. Okay, just a few more seconds to vote. All right, thank you.
So now that you've identified which are the good performing buildings and which maybe aren't, the next step is to understand why the building isn't performing well, because it can perform poorly for a whole lot of reasons. This is one of the tools that a lot of people use, the ASHRAE level 1, 2, and 3 audits to look at the buildings and try to understand their performance. But Each one of these represent an increasing level of effort and time spent on analysis and spent in the buildings. And there are things that you can do, and there are tools out there that can help you shortcut this process and make your audits a lot more useful. So you might see this as going between benchmarking and that level 1 audit. There are a lot of remote auditing tools like First View and First Fuel and a handful of others that can use very basic information about the building's energy usage, very basic information about the building, and can actually begin to analyze its performance. So both of these are examples of inverse modeling, which we'll talk about in a second, but there are other tools out there available as well that can really provide a lot of insight with a lot less effort than it takes to begin to get boots on the ground out in for an audit. So what is inverse modeling? Traditionally modeling, you have the characteristics of the building that you know, and then you have your modeling guesses. And the reality is in modeling that you have a lot more guesses than what you actually know because of the impact of how a building is operated. But what happens when you have an existing building and a lot of those known characteristics aren't actually even known? But you have things that you do know, new things that you know, like schedules and set points, but your guesses then begin to multiply. What is in the envelope? Well, maybe we know what the HVAC started at for its efficiency, but we don't know what it is now. And that's where inverse modeling comes in. Traditional modeling then starts with inputting your best guesses for the building characteristics. You compare it to the actual energy use. You adjust the model parameters. You do that again and again and again and again, and you keep doing that until you match the actual energy usage that you get from your bills or from your metering, and you hope that it's not just a coincidence, that they actually match. Inverse modeling flips that around. So with a year of monthly utility bills for all fuels, simple information like building location, size, and type, it uses a regressive analysis and a data set of existing building characteristics and outcomes that are known to output things like a heating profile, a cooling profile, the gas baseload, and the electric baseload. So if you look at the right, this is called an energy signature. It shows how much energy the building is using at various temperatures. And you can see that the red is the slope for heating, and so as the temperature rises, less and less energy is needed for heating, and as it continues to rise, you begin to see the need for cooling in the building. And of course, some loads are fairly constant over the course of the year. Lighting stays relatively constant unless there's a seasonal component to the building. Service hot water tends to stay relatively constant, not exactly constant, but you can see how this building operates, and the slope of this signature and the magnitude of these various bands can reveal things about the building. And in fact, First View can tell you a lot of what those things mean. The slope of that heating slope will tell you about insulation and about infiltration. When you see things like this where it is heating and cooling at the same time, that tells you that there's something wrong with your controls. If your band for the electric base load is very large, that tells you something about how the tenants are occupying the space. And First you can go in and give you some automatic diagnostics about what might be going on in that building. And what that allows you to do is that's not a replacement for auditing, but it can help you with these various steps. It can help you do them more effectively once your auditor is in the building. So whether you're doing level 1, 2, or 3, they will have more information about the building to be able to know what to look at and what to spend their limited time looking at. And so once you have a good understanding of how the building actually operates, then you can begin to set goals. Where do you want to go with this building? So here we are again with our Boston City Hall with our EUI of 122 and our ZEPI score that is off the scale. What do we want to go? Where do we want to end up with this building? If we do a 30% reduction, well, that's an EUI of 85, which would finally take it to 100, which means that this building would finally be average 16 years ago. And that's what it would take to get just 30% reduction. But what if you wanted 50% reduction? well, then you're looking at an EUI of 60, and you're looking at a building that is better than the code that's in effect right now. What if you want 80% reduction? Say you want to meet the current Architecture 2030 challenge. How do you get there? Well, hitting a 30 is going to take an 80% reduction. You'll have to get to a 25 EUI. So these are the sorts of pieces that you can take as practitioners to your client, or you as the owner can see to know, where do we want this building to be? What are our goals for the building? Do we want to position this as an energy efficient, progressive building? Do we just want to make things better and reduce the costs? How much do we want to reduce the energy costs? And what is it going to take to get there? Because once everyone is on the same page, the design team, the owners, and hopefully the occupants might even be involved as well, then you can begin to say, this is our goal, and therefore, when we're looking at the design alternatives, these are the things that it's going to take to get there. And as you're evaluating all of the steps, all of the options, all of the many, many different strategies that you can employ, and you begin to make the decision about whether or not to pursue these options, this is what tells you, well, these are the things that we need to do to reach the goals that we're setting. So we have one more participant poll for you all. Connie?
Okay. Would you like to speak with a National Grid expert on a current major renovation commercial industrial project greater than 100,000 or 10,000 square feet? I'm going to go ahead and launch this. Okay, just a few more seconds. Okay, thank you.
And there are other ways that you can look at how are we going to set goals, because you could have an absolute goal like this, that it's a certain amount of energy savings or a certain level of performance relative to the rest of the market or the rest of the country or the rest of the world. Or you could look at what is going on in the building and decide we are just going to address the worst issues in the building. And that's why this good assessment is appropriate, because every measure that you pursue is going to have a cost. And if you can identify which are the biggest impact on the building's existing performance, what are having the greatest drag on the efficiency of the building, that means that you as a project team can direct the budget to where it's going to make the biggest difference. So for this building, we see that the gas baseload is high. So maybe that means that it's time to replace the water heater. Maybe there's a process load that can be made more efficient. Maybe there's a gas base load and you have no idea where it's going, and it's time to figure out what is actually happening in the building. And of course, in this one, control inefficiencies. And addressing the controls are often some of the most effective things that you can do, because that is very often a no to low cost measure. And by having a good assessment of the building, you can do these evaluations so that all of the measures can be directed to where they will do the most good. If you hadn't done this assessment, if you just knew this is my building's EUI, you might invest in insulation when the problem is really that you have a massive ventilation issue on the building. And in fact, First View, as we were using it on a new construction project, as soon as a building is occupied, it's no longer new construction, it's now an existing building. And this was a new building, it was meant to be high performance, and the EUI was high, and they didn't know why. And they'd had their facilities walk through the building and do a level 1 audit, do a level 2 audit, and they still couldn't figure out why. Did this, what is really a fairly simple analysis of the building, and identified that the issue was ventilation. And so the facilities team was able to go back into the building and check all of the VAV boxes, and they found that they had several control errors in their boxes, and that was the issue. It was an issue of ventilation that actually wouldn't have shown up in almost any typical audit, because it's something that they really had to crawl in to take a look. But First View was able to point them to it. And so on another project, where the source of inefficiency may not be readily apparent, it is very easy to invest your money in the wrong place, to put the budget not where it's going to do the most good. Another way that you might look at it is, an audit typically, the higher level audits will generate a list of measures and might even give you some project costs and some savings estimates. And this is one of the things that a lot of people look at. They look at simple payback as a metric, but maybe that's not the best metric to be looking at, because if you look at internal rate of return, which is more like how we assess the investments when we invest our money in something, by the second year, a lot of these things are seeing really amazing internal rates of return. And as time goes on, in the 5th year and in the 10th year, you can see that some of these measures that wouldn't even be considered in terms of simple payback, down at the bottom, 4.1 years, a lot of people won't even consider anything with a simple payback that long. But in the 10th year is going to have an internal rate of return that's way better than most people see on most of the investments that they make in their business. And so by looking at the return on the measures and looking at a more comprehensive metric for looking at the return on the investments, you can begin to assess how it is that a business might invest its money, and that they might realize that when they see all the things that they can invest their money in their business, that their building might actually be one of the better things that they can invest in, and that the return on investments of the building can be a lot better than some of the investments they actually might make in the business. But this is the sort of information that they can use to make that decision and to be a little bit more comprehensive than just thinking about simple terms like simple payback. And so instead of looking at just 1 to 2 years, they might look at, everything that comes in under 3 years, or they might just decide that they want anything that is profitable after 5 years, or they may decide that, let's look at that 10-year horizon. We're really forward-looking, and what is the return that is going to be good for us? So we're going to do questions for everyone in just a moment. But before we do that, we want to ask you a couple of questions about this webinar so far. So Connie, go ahead and launch it.
Okay, how valuable has this webinar been to you? When you see the answers, they had to be shortened a bit. So there you go. Okay, just a couple more seconds. So far, it looks like everybody's been pretty happy with the information presented today. All right, go ahead, Sean.
All right. So as Connie said, you've had the opportunity to enter questions into your dashboard as we've gone along, and Connie has been collecting those, and you still have, since we have a few minutes left in our allotted time, to submit some questions. And so we'll go ahead and take some of the questions that you have asked.
Okay, well, the first question that we have is, do you consider health benefits for employees in deeply efficient buildings?
We think that you should consider that. That is one of the non-energy benefits that can be gotten from deep energy retrofits. There's been a lot of literature around that, about the gains in both the health and in the productivity of occupants of buildings, whether that's the productivity of office users, whether that is the sales performance of retail space, or the test performance of students in schools. There have been a lot of studies that have gotten into these non-energy benefits. And so that is something that you, as you talk with the individual owners about these projects, that you should certainly consider, because these can give you another reason to go ahead and do a deep energy retrofit. And we'll be talking about that topic specifically quite a bit more in the second webinar.
Okay, this next question is for Tracy. Will National Grid be offering a block bid grant?
Whoever asked that question, I'm not familiar with the term. Sean, are you?
I'm not.
Maybe we can get a little bit more context on it, and or send me an email, and we can look further into that.
Okay. The next question is, how about energy conservation and water and waste treatment application at industrial plants? And a side note on that, is it eligible for a grant?
Looking at process loads, especially in industrial and in those kind of hybrid buildings, you see a lot of commercials that actually have either a light industrial or a process load-like usage inside the building. Looking at those are certainly a way to look at how to improve the overall performance of the building. Improving the process load efficiency not only reduces the amount of energy that is used in the process itself, but processes almost always involve significant amounts of waste heat and high ventilation needs. And so if you can bring down the levels of waste heat, if you can bring down the amount of cooling that's needed and the amount of ventilation that's needed on the process load, then you see an additional efficiency coming from the building itself. As far as the grants, Tracy, do you have an answer for that part?
Yes, absolutely. That would be something that we would look at under our custom program. So there certainly would be incentives available from what code is requiring you to do to the condition that you're creating. So that delta between the code compliance and where you're going, that's usually an area that we see significant savings and can offer a lot of support to those projects.
Okay. Next question. How do we sell this idea of deep energy retrofits for a client who is looking for immediate payback? What is the #1 aspect that can be brought up to the client in the initial stage for them to even consider this retrofit project?
I think one of the really good selling points for something like a deep energy retrofit is looking at this assessment starting point, that if you can give the client the context of look at how your building compares to other buildings in the market, how it compares to the way that the real estate market is moving as far as its targets into the future, what counts as a sustainable green building. That sort of context, especially if the client begins to see their building as an absolute dog, that can really give a lot of context and can really help spur them on to make a decision, because owners, especially in commercial and who are investing in their properties, to see their building lag behind, that is one of the things that's going to have a huge impact on their bottom line. And to be able to compare where they are to what the current code in can be really useful, because we don't build Class B new construction. That's not how our market works. All new construction is Class A, which means that the life of a building is a life of starting in Class A, going down to B, and then maybe ultimately to C, and there are a few markets out there where there's stuff that we really should call a D. And so that means as they are looking for bringing in rents, as they are looking for the value of the building if they're looking to sell it, that if your building is really lagging behind what Class A investments are doing, what Class A real estate represents out there in the market with their levels of efficiency, that can have a real impact on the building's ability to get a good resale price, to be able to bring in good tenants, especially as tenants are paying more and more attention to whether or not a building is a green building or a high performance building, or at least whether or not this building is one of the really bad buildings. And this becomes even more critical for these owners if you begin to point to things like the disclosure ordinances that we're seeing in so many cities, especially in the Northeast. because that is giving the market a tremendous amount of information about what the buildings out there are doing. And so the market, before, a lot of this was opaque and you could just ignore the fact that your building was inefficient. That is getting harder and harder to do. The market is going to have the tools to be able to respond in pricing and in demand to poorly performing buildings. And so it really is a market case for a deep energy retrofit when it's appropriate for the building, that this is what it's going to take, not to set yourself apart necessarily, although this can be the way that you set yourself apart, but this is what it's going to take just to keep up with the local market, just to keep from being bumped down the class A, B, C ladder even further, because new construction is displacing all of the existing buildings to go farther down unless they can find other ways to keep up.
Okay. Next question. Is it possible to identify the best candidates for retrofit by building type rather than a specific building, especially if you are interested in Z&E retrofits?
That is one of the reasons that a system like ZEPI is really useful, because in office buildings, you can compare different EUIs to each other. As long as all the buildings are office buildings, you can see that this EUI is higher, this EUI is lower. But we all know that assemblies have a lower intensity usage than a type like an office, which has a lower intensity of a usage like a restaurant, which has the lower intensity like a usage like a fast food restaurant. And of course we have labs and are often at the very top, and hospitals. And so it begins to be really difficult to compare across building types. But ZEPI actually accounts for all of that. When it looks at the baseline, it's looking at your particular building type. And so you'd be able to compare against others. And the reality is that all real estate is local to a certain extent. And so that means that using something like ZEPI, you can begin to look at the market that you're in and see how the buildings in your market are doing. The reality of our building codes is that they have addressed different buildings to a different level of success. Our building codes are really good with offices and are good with retail spaces, but haven't been as good at really bringing down the energy usage of some of these higher and more unusual building types. And so that might be the place to look at the places that aren't as addressed as well as code. But it's a matter of looking at the market where you are, because in one market, the offices might actually be doing really poorly, and there could be an opportunity there.
Okay, well, I think we have time for one more question, and anybody whose questions weren't addressed on air today, especially if you've asked for National Grid information, we'll make sure to have somebody follow up with you at a later time. So our last question for today, is there a metric for the value derived to the building owner in increased rents or value of the property after a deep energy retrofit?
I know that there have been a lot of assessments, smaller studies done about that kind of impact, but right now I think that the data is too limited to be considered much more than anecdotal. And I think that this is one of the things that we have tried to focus on. This is that deep energy retrofits are a large part about finding the right building, about applying them to the right building and finding the right opportunities. And so since that baseline is so varied, I think it would be a little bit difficult to just assign a single metric. And so it's really a matter of looking at that building itself, looking at the building that you have the opportunity, assessing where it is and assessing what the opportunities for improvement, and then translating that into a metric that the owner understands, whether that's internal rate of return or whether that's reduction in utility bills. And so we'd like to thank all of you for joining us. As a reminder, we talked about how to assess the building and set goals this time. In the coming webinars, we'll be talking more about scoping, implementing, and operating the buildings. So that is our part 2 and part 3, best practices and technologies and strategies, and getting to zero net energy. And we want to thank you all for joining us. It's been a pleasure to have you, and you'll be hearing back from us if you've had any questions. So thank you all very much, and enjoy the rest of your day.